Hey everybody, welcome back from the long break. Today we've got a fun math assignment that we're doing. It's not hard, it's nothing that's necessarily new. However, it is going to use some of the things that you have learned in the past or last year and this year, okay? So we're going to be finding areas of random shapes of objects, all right? So here's one shape. It looks like it's a couple half circles, some triangles, maybe parallelogram, maybe a rectangle. There's a lot going on here. We want to find the area of the shape. Well, there's a couple ways you can do it. How I would probably do it is I'd look, hey, I've got two halves of the circle. If I have two halves of the circle, isn't that a whole circle? So I have one circle that has a radius of 8. So what's half of 16? It's 8. And the formula to find the area of a circle is pi r squared. Okay. Then we also have a parallelogram. For parallelogram, the formula is base times height. Well, what's the height of the parallelogram? It's 11. And the base, or how wide is it at the bottom or at the top, is 18. Okay. So up here we have pi times r squared, which is 8 squared. Then we're going to add base times height, so 11 times 18. Let's see what we get. Now for these problems, we will want to use the actual value of pi. So just use the pi value on your calculator. So we've got pi times 8 squared plus 11 times 18 gives me 399.06. This wants us to round to the nearest tenth. So 399.06, what would that round to? Let's basically round to 399.1. Well, let's cross our fingers. Let's hope this is right. Whew, we did it! Let's try another one. All right, this one looks pretty easy. Let's see here. We have a rectangle. What is the size of the rectangle? It's 11 times, if you said 5, you are incorrect. This little piece right here is 5. We need to know the entire length. So wouldn't it be 10? 11 times 10. Very good. Then we also have a half circle. Well, we know that the formula to find a circle, the area of a circle, is pi r squared. So if we have a half circle, what would we do with it when we're done? Well, we could just divide by 2. Okay. So let's see here. We've got that plus pi. Our radius is 5, so 5 squared, all divided by 2. Okay. Let's plug that one into a calculator. I can show you what that would look like on a calculator if you want. We have 11 times 10 plus pi times 5 squared divided by 2. Gives me 149.26. What would 26 round to? Round to 3. So we've got 149.3. 149. 49.3. As you can see, I'm just breaking it into smaller shapes. That's all that I'm really doing. Okay, it's nothing super crazy. Ooh, what about this one? There's two main ways that I can see doing this one. The first way is to find the area of the rectangle, then subtract off the half circle, then add in a half circle. The second way, which I think would be easier, what if we just take this half circle and move it right there? Then isn't this just one giant rectangle? Yeah. What's 10 times 8? 80. Ta-da! want you to try this one. On your mark, get set, go. All right, pause the video. You should have the answer by now. Let's do it together. 6 times 8 is 48, which would be the entire area. But we need to subtract off the half circle. What is the radius of the half circle? It's 3. Okay. So we have pi times 3 squared divided by 2, because it's just a half circle. I'll bring this in. Do some math. 48 minus, let's see here, pi times 9, because 3 squared is 9 divided by 2. It's 33.86, which is 33.9. Let's see if that's right. 33.9. Very good. If you got 33.9, way to go. Let's see if we can find another one that's a little bit different looking. Ooh, this is a cool one. All right, I'm going to try this one. Mark, get set, go. See if you can figure it out. Okay, you should have paused the video. You should have the answer by now. If you haven't finished, try pausing the video real quick. All right, let's do this. So the top is 5, the bottom is 2. We want to find the area. Well, what you do with the trapezoid, with this top piece, you have to figure out that average, okay? So basically, what if we took this piece of the triangle and moved it over to right there, made it more of a rectangle, okay? Well, in order to do that, we have to figure out the average of these two. What's the average of 5 and 2? The average of 5 and 2 is 3.5. Okay, so if we did move that other triangle over here, this would no longer be a length of 5, it'd be a length of 3.5. When you think about it, if you take 1.5 off of this right side and move it over, well, 2 plus 1.5 would be 3.5. Okay. So if we have a rectangle that's 3.5 by 4, well, 3.5 times 4 plus the area of this half circle, which is pi times 2 squared over 2, which will give us, so here, 3.5 times 4 plus pi 2 divided pi 2 squared. Well, divided by 2, additionally 2 pi. It gives me 20.3. Let's see if that's right. No, what did we do wrong? Oh, what did Harper-Smith do wrong? The radius wasn't 2. The radius was 1. Harper-Smith messed up there. Darn it. Well, we learned a valuable lesson. Don't be like Mr. Harper-Smith. Okay. All right. Try the assignment. The assignment today is listed as, let's see, what did I have it listed as? 3.1.1 area of irregular shapes. That is today's assignment, okay? It's just a whole bunch of different shapes. You go through and find the area of those shapes and you're set, okay? This does leap. You're probably thinking, is this just some like random assignment, Harper-Smith? Why are we really doing this? It's leading into calculus, the second part of calculus. The first part of calculus that we go over is doing derivatives. A derivative tells you what the slope is. With calculus, the second part of calculus, it's finding the area of shapes. Right? So the first part of calculus is finding slopes, gradients. The second part of calculus is figuring out areas of shapes, very strange shapes. So we're just starting with this today as far as shapes go, because I'm sure you guys can do this. Anyway, let me know if you have any questions. That's what I'm here for. I'll see you guys later.